Welcome. This is going to be the final exam review, part B2. And basically, we have different polynomials here that we're supposed to factor. So for example, on a problem like this, I ask myself, what numbers can I factor from 3x and 18? And the answer will be 3. So once I select what I can factor, then I do the division. 3x divided by 3 is x. 18 divided by 3 is 6. On the following problem, I have 14. Let me make it a little bit bigger so that we can see better. So here we go. Now this one I have 14w to the 5th x squared minus 7w to the 3rd x, and basically can I factor anything from 14 and 7? The answer is yes. I can factor out a 7. And for the w, I look for my smallest exponent. My smallest exponent is 3, so I'm going to factor out a 3, w to the 3rd. And for the x, my smallest exponent is x to the 1st. So here I have decided what I'm going to factor. Now that I've decided, I'm going to do the division. 14 divided by 7 is 2. W to the 5th times divided by w to the 3rd is w to the 2nd. X squared divided by x to the 1st is x to the 1st. And then the next one is negative 7 divided by 7 is negative 1. W to the 3rd divided by w to the 3rd, the w cancels, and so does the x, so I'm only left with the 1. On the next problem, I have 5x squared plus 4x cubed. There's no number that goes into 5 and 4 other than 1. And for the letter, I can factor x to the 2nd. So that's why I write x to the 2nd here on the outside. And then I do the division. 5x squared divided by x squared is 5. 4x cubed divided by x squared is 4x. Okay. Number 4. What number can I factor from 20 and 45? The answer is 5. This would be the smallest exponent is y to the 3rd. And my smallest exponent here for z would be z to the 3rd. Once I decided what I'm going to factor, let's go ahead and do the division. So let me make it bigger again. There you go. 20 divided by 5 is 4. Y to the 8th divided by y to the 3rd is y to the 5th. Z cubed divided by z cubed, the z cancels. Okay, and then 45 divided by 5 is 9. The y to the 3rd cancels. Z to the 5th divided by z to the 3rd is z squared. Okay, on the final exam, I'll look at problem number 1 and 4. There will most likely be a question, multiple choice on, I'm sorry, not multiple choice, but for you to write the answer. So these factoring problems, actually it's not going to be multiple choice. You're going to have to actually do it just like we do here, but as you can see, it's pretty simple, okay, and straightforward. Alright, so I'll look at problem number 1 and 4, because you'll probably see something very similar on the final. The next problems are trinomials, something that has 3 terms. Also, this one has a 1 over here. So basically you multiply 1 times 48 and you get 48. And basically then you create a list of numbers that give you 48. So basically, using your calculators, you can do 48 divided by 1 is 48. So 1 and 48. Then you do 48 divided by 2. And we get 24, so we write 2 and 24. Then we do 48 divided by 3, and we get 16. Then we do 48 divided by 4, we get 12. The next number would be 5. If I try to divide it by 5, I get a decimal, so that means 5 does not make the list. The next number would be 6, so 48 divided by 6 would be 8. The next number then would be 48 divided by 7, and again I get a decimal, so 7 is not part of the list. The next number on the list would be 8, but since 8 is already part of the group, we know we have finished creating our list of pairs. Now that we have a list of pairs, we're looking for a pair of numbers that when added or subtract will give me my middle term, in this case being negative 16. So what number would give me 16? Well, 4 and 12 give you 16. So once you decided that these two give you 16, you have to decide on the sign. Always look at the biggest digit, in this case 12. The biggest digit will always have the same sign as the middle term. Since the middle term is negative, that means the 12 will be negative. And once 12 is negative, you ask yourself, does the 4 have to be positive or negative to give me a negative 16? Well, the answer would be it has to be negative. So negative 12, negative 4 gives you negative 16. And then final check. A negative times a negative does give you a positive. Yes, it does. So that means this will be your answer. Okay, so let's go on to the next problem, problem number 6. Problem number 6 is very similar to the one we just did. Basically, you multiply 1 times 30, get 30. You create a list of numbers that will give you 30. So 1 times 30, 2 times 15, 3 times 10, 5 times 6. Once you have this list, focus your attention on the middle term. The middle term is 13. You're looking for the pairs of numbers that give you 13. Well, 15 and 2 give you 13. 10 and 3 give you 13. Once you decided on these two pairs, then you focus your attention on the sign. The sign of the middle term is negative. So therefore, your biggest digits, 10 and 15, will have to be negative. Once you put the negatives there, then you ask yourself, negative 10 plus 3 or minus 3 will give me a negative 13. And then we come up with it has to be negative. Same thing with negative 15. Negative 15 plus 2 or minus 2 will give me negative 13. The answer is the 2 has to be positive. So now I have these two pairs, and then I do the final check, which is the signs. A negative times a negative gives me a positive. Yes, it does. So that means this pair works. A negative times a positive does not give me a positive, so you can even cross this out because this fails the test. So therefore my answer will be x minus 3, x minus 10. Alright, problem number 7. Again, very similar. You multiply 1 times 42, create a list of numbers that give me 42. Once you have this list, which pair will give me 11? Well, 14 and 3 give me 11. 14 has to be positive because 11 is positive. And to give me 11, then the 3 must be negative. Final check. A positive times a negative. Does it give me the same sign as this guy right here? Well, a positive times a negative is a negative, not a positive. So that means 3 and 14 fails the test. Is there any other pair that will give me 11? The answer is no. So therefore the answer here will be prime. Okay. Next problem. Next problem does not have a 1 in the beginning, but always before you do anything, ask yourself, can I factor anything from all three terms? And in this particular case, you can factor out a 2. You can factor the 2 out, then 2y squared divided by 2 is y squared. Negative 6y divided by 2 is negative 3y. And negative 36 divided by 2 is negative 18. You just keep the 2 on the outside and then focus your attention on the inside. Multiply the 1 times 18. Create a list of numbers that give you 18. Out of this list of numbers, which one will give you a 3? In this case, 6 and 3 give you a 3. Sign of the biggest is negative. Therefore, the 3 here has to be positive to give you a negative 3. Final check. A negative times a positive, does it give you a negative? Yes, it does. So that means I can use these numbers as my part of my answer. Don't forget the 2. Okay. Most likely it will be a question like this, like problems 5 through 8, where you have to factor and the number in front of the y square or the x square is 1. So please note this, okay? These will be problems that will not be multiple choice. You're basically going to have something like this and you will be asked to factor, okay? Alright, let's go on to the next problem. So let me move over here. Problem number 9. If you look at problem number 9, first thing I notice is that the number in front of the x squared is not a 1. I started out by asking, can I factor anything from all three? And the answer is no. So therefore, I multiply 7 times 3 is 21. Then I create a list of numbers that give me 21. Once I have my list, I'm looking for something that would, when added or subtracted, give me 22. In this case would be 1 and 21. Sign of the biggest will be negative because the middle term is negative. And negative 21 to give me negative 22, therefore the 1 must be a negative. Once I have that, copy the first term, split the middle term as negative 1x, negative 21x, bring down the 3. Now that I have 4 terms, group them in pairs. See how I grouped the first 2? And ask yourself, what can I factor from the first 2? I can factor out an x. And if I factor out the x, what I'm left with 7x. And 1x divided by x is negative 1. On the last 2, what can I factor from the first 2? Can factor out a negative 3. So negative 21x divided by negative 3 is 7x. And positive 3 divided by negative 1 is negative 1. Looking at this, what can I factor from these two guys? What do they have in common? They have in common 7x minus 1. If I remove the 7x minus 1, what I'm left with? I'm left with x minus 3. Alright. And let's go on to problem number 10. Very similar. Multiply 8 times 15. You get 120. Make a list of numbers that give me 120. Once you have that list, look for the middle term and look for a pair of numbers that when added or subtracted gives you a 2. In this case would be 10 and 12. Make sure the signs work. Sign of the biggest, same sign as the middle term. And if this is positive 12 and I want positive 2, then this 10 has to be a negative. Final check, a positive times a negative is equal a negative. So that means I can use these two numbers. So I copy the first term, split the middle term, copy the last term. Now I group them in pairs. Whoops. Excuse me. There we go. Sorry about that. So we group them in pairs. So what can I factor from the first 2? I can factor out a 2x. 8x squared divided by 2x is 4x. Negative 10x divided by 2x is negative 5. Bring down the positive sign. What can I factor from 12x and 15? I can factor out a 3. So 12x divided by 3 is 4x. And negative 15 divided by 3 is negative 5. Now look for what they have in common. In this case, it's 4x minus 5. And if I remove the 4x minus 5, I'm left with 2x plus 3. And that's my answer for this problem. Okay, the next set of problems, problem number 11, is similar to the previous ones. The only difference is now you have an equal sign. So whenever you have an equal sign, this is going to be a quadratic equation, and the first thing you need to make sure is that one side equals 0. This particular problem, we already have one side equals 0, so that's great. And what we're going to do is just imagine the equal sign and the 0 is not there for a second. And we're just going to factor just like we did on the previous problems. Multiply 1 times 18, create a list of numbers that give you 18. Look for a pair of numbers that give you the middle term. Make sure the signs works. And when they works, please write the answer just like if you were factoring. Okay? The only added thing is that you have an equal 0. And because you have the equal 0, you need to take one step further, which is you need to break down the two answers. Y plus 2 equals 0, y minus 9 equals 0. We usually don't write that out because you can do it that mentally, but basically you imagine that you write y plus 2 equals 0 and you want to solve for y. So you're going to move the 2 to the other side and it'll become y equals negative 2. Same thing with y minus 9. Imagine you have y minus 9 equals 0. If we move the 9 to the other side, then it will become y equals 9. Okay? Alright, let's take a look at problem number 12. Problem number 12, we have 3y squared minus 11y plus 6. And again, we want to multiply the first times the last. Get a number. Create a list of numbers that give me 18. Once we have that list, look for the numbers, the pair of numbers that will give me the middle term. In this case, it would be 2 and 9. Make sure the biggest digit is the same sign as the middle term. And in this case, it's negative. So negative 9 minus 2 will give me negative 11. So therefore, I know that 2 is negative. Final check. A negative times a negative gives me a positive. So that tells me that this works. So I will copy the first term. I'll split the middle term, and I'll copy the last term. Okay, now I group them in pairs, and I ask myself, what can I factor from these two? I can factor out a y, so 3y squared divided by y is 3y. Negative 2y divided by y is negative 2. Bring down the negative. What can I factor from the last two? I can factor out a 3. So 9y divided by negative 3 is 3y. 6 divided by negative 3 is negative 2. Look for what they have in common. They have in common 3y minus 2. So if I factor that out, I'm left with y minus 3. So basically, split the two equations. This would be y minus 3 equals 0. If I move the 3 to the other side, it becomes y equals 3. Here, I wrote it out. 3y minus 2 equals 0, so I need to solve for y. Move the 2 to the other side, becomes positive. Divide both sides by 3, y equals 2/3. Okay? Alright, let's go on to problem number 13. Here I have problem number 13, and I look at that. I have one side equals 0. So I ask myself, what can I factor from these two terms? I can factor out a 3x to the third. So if I divide 3x to the fifth divided by 3x cubed is x squared. Negative 75 divided by 3 is negative 25. And x cubed divided by x cubed, the x cubed cancels, so that's why I only left with 25 here. Now this is a perfect one of those special factors where you can write x plus 5 times x minus 5. So now that I have three terms here, I want to set each one of them equals 0. So 3x cubed equals 0. Divide both sides by 3. X cubed equals 0. Take the cube root of both sides, x equals 0. In this case, x plus 5. Imagine in your head, x plus 5 equals 0. Move the 5 to the other side, becomes negative 5. And in this case, move the 5 to the other side, becomes positive 5. So there's three answers in this particular problem. Okay? Problem number 14. This is a little bit different than the previous ones because this time I don't have a 0 on one side. So my first order of business is to make sure that one side becomes 0. How do I do that? In this case, I move the 25y and the 10 to the other side. Once I move there, I combine like terms. Also, notice that I make sure that the 25 is in the middle and the 20 is at the end. So in other words, make sure they're in order from the highest exponent down to the smallest. Okay, so y squared, y to the first, no y. Alright, now before I start factoring, I notice that before I try to do my strategies, I try to ask myself, can I factor any number from all three terms? And in this particular case, I can. I can factor out a 5. Once I factor out the 5, I get a simpler trinomial with a 1 in the front. So 1 times 4 gives you 4. Create a list of numbers that give me 4. And looking at that, I'm looking for something to give me a 5. So in this case, it would be 1 and 4. And since there's a 1 here, I can go directly into the parentheses. So this would be 5 times y minus 1 times y minus 4. And if I split this will be y equals 1 and y equals 4. Alright, the following problems is pretty much the same as the ones before. Just make sure that you make sure that one side equals 0. So please move the 6w here, for example, to the middle, and then you just factor and make sure you solve for each letter. Okay, problem 18 is very similar to. So are the other problems. So here are some more problems. Basically, make sure one side equals 0, and then do the first time last, create a list of numbers, make sure you're getting the middle number, and do the factoring. Okay, so I'm not going to go over all the single problems because they're pretty much the same steps, but these are very good problems to practice. Okay, again, for the final, you are going to have a question like this, which is an equation where there's an invisible 1. You're also going to have another equation where you don't have an invisible 1, you're going to have a number in front. So these are very good problems to practice. Okay, and this concludes the and also furthermore, here on the very back you have some more problems of the simple factoring. Remember, you're going to have one simple one like this one, and probably one with letters like problem number 25. So you want to take a look at that. And here are some more practice problems, and here are the answers. Alright, this concludes the final exam review part B2. Thank you very much for your time, and have a great day.